right. Thank you so much for listening. Yantoro Neko, it's your turn.
Alrighty. I guess with that,
Quick note.
Toki yan aleo, nimimi li yan torineko, toki ni navi toki ni okama sona toki pona don kulupumi, sina toki ini la okama pona, ma toki pona wia li kama tomo sina toki ni on la okama pona kinkulupu pali pa peli wele yo yan sin. Yo, I'm Yan Torineko, otherwise known as Floppy. Welcome
Let's
to the
go.
Toki Pona VR meetup. And today I'm your panelist. So yeah, today we're going to talk about languages, encryption, and using languages for encryption. But before I do that, I want a chance to reintroduce myself a little bit since we have a lot of new people. So I started playing VRChat around mid-2020. That was when COVID was really peaking. I had a cool work at home order where I basically wasn't allowed to go into the office anymore. And that was kind of a bummer because we had an awesome culture. We got lunch every day together as a team. We played board games every Friday. And I really missed it and I was kind of lonely. So I took the plunge. In March, I bought an index, waited for 3 whole months, and eventually got it. And yeah, I was pretty happy to find out that VRChat's pretty fun. After that, in 2021, I got kind of involved with the development scene. So this right here is the Arduboy. It's one of my favorite open source game systems. It's a little 8-bit Arduino-based game system with a monochrome, beautiful LED, OLED display actually. And yeah, I wanted to share my love of it with the people in VRChat. And I wrote this little engine that basically lets you copy paste C++ code onto HLSL, and I ported a couple of games that way. And yeah, that was pretty fun. After that, I kind of branched out and started exploring other social VR platforms too. I particularly like the open source stuff, but yeah, you might see me around Altspace or Mozilla Hubs and things like that every now and again. But yeah, and if you're bored, ask me about the Quake project. But anyway, yeah, let's talk about how bad I am at learning languages. So I tried learning Japanese several times in my life, like any nerd might, and I used fancy tools like WaniKani. I used textbooks like Genki in Japanese for busy people. I used the Pimsleur method, which is like an audio SRS method developed in the 70s, and those didn't work for me. Then I took college classes. I took college classes again. I mean, I got A's in the classes, but I never learned anything somehow. And I don't know. Then I also failed Arabic, failed French, actually failed. And then I also tried learning Esperanto in the early 2010s. Didn't really do well at that, but I got good enough at Lingua de Planeta to struggle through Alice in Wonderland. So that was kind of cool. What else? Now let's talk about Toki Pona so I discovered when I was really, really sad, my little brother, he's like, hey bro, there's a language out there that might be for you. It's only got 120 words, and you might like it. And I'm like, what? No way. And then he showed me Jan Misli's conlang critic video, and I'm like, oh, yes way. Okay. Heck yeah, this is great. And so I kind of spent a week learning all the words, and then I had them all memorized. And then I was like, okay, this is actually starting to feel real. But when I joined in Discord calls, it wasn't really for me. I just kind of feel stressed in a big Discord server. And so I wanted to find other people who liked speaking Toki Pona in VRChat. And basically, yeah, I don't know. I've met Project Babel through a good friend, Kwane Rio, and it's been just super fun since then. Yep. After that, we have to take a look at Project Babel. So you've seen that name around the Discord, but some of the new people here might not be familiar with Project Babel. Well, they're a multilingual community that celebrates lots of languages. So this can be constructed languages, but also just natural languages and interesting writing systems. People teach classes on whatever. And it is the people who founded Project Babel are based in Japan. So all the events are in JST. Technically, this event right here, right now, is a Project Babel event, actually. It's on the calendar, so that's cool, yeah, check out Project Babel. But yeah, Umi Hotaru founded it last year. It had its anniversary recently, and yeah, they've been speaking conlegs for a year. And they also were the first people in VRChat to host Toki Pona class. So that's pretty sick in February. Let's see. After that, we have our humble meetups. We started out with just 4 people in our meetups. This is me, Jan Lasokasi, and Jan Pepan. We did a mystery escape room at our first meetup. And yeah, it started out really small. I also made that old world that you might be familiar with. Showed it through the community meetup where Jan Temeli helped like translate and explain some of the Toki Pona concepts to the VRChat developer community. Yeah, so that's pretty much like the early history. But now we've kind of got into where we are today, which is Ma Toki Pona VR. So we're an event-oriented community. We use VRChat for our official events, and we're dedicated to speaking Toki Pona. So yeah, welcome, Okama Pona. In May, we converged on our current format when Jan Kekan-san joined us and started teaching classes every single meetup, literally every meetup, and recording them. So thank you. Yes. And so yeah, once again, our format's simple. We have a class, a game, and a field trip. So yeah. Class, game, and a field trip. But today marks a change. We are reframing it slightly. As Jan Kekan-san talked about earlier, now it's going to be a panel, a game, and a field trip. So the panel can be anything you want. You're watching the first general panel today. And when no one's doing a panelist, Jan Kekan-san can continue teaching classes and things like that. But if anybody does have a fun idea that they'd like, please reach out to Ahmad, and we'd love to give you space and have you show off your cool thing. But anyway, I'm Jan Toduneko, otherwise known as Fuopi. Today we're going to be talking about languages, encryption, and using languages for encryption. And if that sounds interesting, I would like to have y'all who are interested come to the classroom, because now we're moving, baby. Let's go. Meow.
Yanale Otawa Tomo Sona.
Yeah. Ponamute.
Oh, looks like somebody has text. Let's see if we can erase that text.
あれなんか配置が変わってる。
There we go.
知らなかった。
Beautiful.
Yeah.
Beautiful. Where
There's
did I
still
put that
some-
camera?
There's still some drawing there.
Oh yeah, can you erase it? If it's local, I think. I don't see it on my screen. There we go. Nice. And yeah. Cool. Yeah, feel free if you see some text, just give it a good old wipe. We'll start in 1 minute. And oh yeah, by the way, so now that we're in the classroom, before I had everyone's voices disabled, I'm going to be taking questions during this class, so I'm enabling voice recording starting now. Just a heads up. But anyway, actually wait, no, I'm not, because the other people are. But yeah, voice recording is starting now though. Anyway, so
Kekan-san, you stole my seat.
but anyway,
Mi pakala, mi kentawa.
cool.
Bona.
All right, so now next slide. Yep, so we're bringing encryption to real-time spoken speech without the use of a computer for fun. Now, I sent this innocent little message to a bunch of friends on Discord, like a dozen or so, and it started off with just TA, exclamation point. And then I followed it up with SKAKKEM. Now, what I'd like you to do is, y'all speak Toki Pona. Can you decode it? I'm gonna give you 2 minutes.
Tokia.
Let's go. Grab a pen and try decoding it. And don't worry, if you don't know what I'm talking about, in 2 minutes, I'll explain the whole process. So don't worry. We'll go through it step by step. But if you want to, I want to give you time to try to figure it out.
Ili nasa tan semela misoneni.
All right, so let me give the first hint. The first hint is the first message says Tokia. And once again, the context is I opened a Discord DM with no context, didn't explain anything, I just said 2 messages. Here's the second hint. The person replied with this. Cool. So with that, I think, why don't we walk through it together? So this is actually encoding. It's kind of glossy encoding of the Toki Pona, just the normal language itself. What we're doing here is we're using the first letter of each word only of Toki Pona words. So yeah, the first one says Tokia, and the second one says Sinekena alaken kute mi. Now you might be scratching your head like, how do we get to that conclusion? A lot of it is guesswork and experience, but it's been surprisingly like workable. So when you start, based on context, we started the sentence with S and we ended it with M, and based on experience, my mind just kind of jumped to S being Sina and M being M. And that's just kind of what happens a lot in Toki Pona. You start sentences, if it starts with the S, it might be Sina, and end with me. After that is E, which is, since we know that this is me, this is going to be the direct object marker. And then after that, we have the ken ala ken portion. Now this is one of the first kind of mystery ones, but since we put a question mark at the end, we know that we're asking a question. Now there's two ways to ask questions in Toki Pona, right? You can do verb ala verb, or you can do anuseme. And since we don't see anuseme at the end of the sentence, we know it's going to be verb ala verb. And so here we go for ken ala ken. And the real mystery here is kute. How do you know it's kute? Well, since it's the beginning of a Discord message, once again, chances are we're talking about something related to communication. Kute is a communication-related word that begins with K. And yeah, that's pretty much where I go with that. And yeah, so then the response is Biken kute, nili pona a. So if you think this is kind of a neat system, you might be thinking, hey, what? Does Toki Pona only need 14 words if we just speak the first letter of each word? And my answer to that is maybe. It kind of works, but we only get about like 80% like understanding between each other before we start to hit awesome divergences in what we're saying to each other. It's actually really cool. So the grammar works out correctly, and we're like talking and talking, and then after a certain point, we might enter an alternate universe where the conversation grammatically checks out, but doesn't make sense. So that happened to me a couple of times. But for a prototype for something, I think it's useful because once again, we are trying to build a real-time spoken encryption system without the use of a PC. So with that goal in mind, this is a stepping stone. But to understand that goal, I need to talk a little bit about one-time pads. This system uses a one-time pad. And if you don't know what that is, we'll start with the basics. We'll start with one of the most simple ciphers out there. And you all probably, if you have security experience, you probably know exactly what I'm talking about. You're right, it's opposite day. So if you're familiar with opposite day, you know that during opposite day, yes means no and no means yes, right? So today is opposite day. I said yes. What does that mean? It means no, right? Yeah, you got it. Let's ride.
Then it isn't opposite day.
So opposite day, I consider to be like the most simple cipher. But yeah, that's pretty much it. When you hear the word yes, you think no. That's the point I'm trying to get across. When you hear no, you think yes. Now let's go to the next cipher, the Caesar cipher. So the Caesar cipher is a pretty simple one. It rotates the alphabet by a fixed number. And I'm going to draw it out for you with a simple message. So consider our English alphabet, right? We have the letters A, B, C at the beginning of the alphabet. And we're using a key with our Caesar cipher where the key is +1. Well, what ABC would turn into when you encoded it with the Caesar cipher, it would turn into BCD because we're adding 1 to the whole message uniformly. And that's pretty much all the Caesar cipher is. So putting it into context, you have you and you want to tell your friend like a little secret message, right? Because this is what we're using our cipher for, right? We want to speak, but we don't want Jan Ike to be able to hear us, you know? Like, so that's what we're doing. So you say, hey, we're going to use a key of +1 when we talk now. And you both know that we're using a +1 key. You both have that knowledge ahead of time. And then you speak BCD. And then when your friend hears you, when they hear BCD, they're going to be like, oh, today is Caesar Cipher Day. And on Caesar Cipher Day, we're using K+1. So for everything I hear today, I'm going to reverse it. And for everything I say, I'm going to add 1. So your friend will hear BCD, and then they're going to reverse it back to ABC. They're going to decode it. And yeah, that's a Caesar cipher. But now we're not using a Caesar cipher because honestly, well, they're not very secure. All you do is have one number that represents how much you want to rotate the alphabet. That doesn't really do much for us.
Huh?
We're going to use a one-time pad. And so that is a little bit more complicated than a Caesar cipher, but it's a lot more secure. So consider our ABC message again, right? ABC. In a Caesar cipher, it uniformly applies to every single letter just the same. But in a one-time pad, every single letter has its own key. And we just keep on generating a super duper duper long key for every message. So let's generate a key right now. That's the same length as the message. We got 412. That's our key, right? And so our ciphertext for this one-time pad encoded message is going to be A+4, which A, B, C, D, E, B, C, D, C, D, E. Yeah, so it'll be ECE, right? And so going back to you and your friend talking over the phone or whatever, you know ahead of time that your key is 412, right? You were in class one day, maybe you like slipped a toilet paper with like some pen on to your friend, and you're like, hey, 412 is the code for today, right? And then so you both know out of band that the key is 412. And now over the phone, what you say to them is ECE. Right? And so when they hear ECE, your friend is gonna go through each letter that they receive and go through each letter of the key. Whoops, I wrote it wrong, but yeah. They're gonna go through each letter of the key and decode it one by one. So let's do it. E4 becomes A. And then they heard C at 412. C minus 1 is B. And then E, and the key is 2, is C. And so that's the basics of a one-time pad. But there's some caveats. One, key exchange is pretty tricky. You literally have to give your friend a whole notebook with like pages and pages and pages of keys that are super long. They have to be longer than the message itself, because as soon as you run out of key, you can't talk anymore. So you either have to like tear off a new page of the notebook and like continue talking with the second page, or stop. Or talk shorter, I don't know. So it gets kind of tricky. But that's the system we're going to use because it's insanely simple. However, it's not simple when you do what I tried to do in 2018. So I actually came up with this idea in 2018, and I wanted to use the Japanese syllabary for this problem. And like we said earlier, like the key itself is kind of problematic. You have to either exchange a notebook or memorize a terribly long key, right? That's a lot of work. But that aside, we're doing that. So that's happening. So don't worry about that. So problem number 2, though, is that you need to break the word into its sounds if you use a syllabary, right? So imagine that you have some sounds and then you transform them, right? And now it just sounds like gibberish that's like kind of hard to say. And then you speak it, and then your friend listens to that gibberish syllable by syllable. They unscramble it in their head, trying to keep the sounds without forgetting them, and then re-block them into actual words. That's kind of tricky. And so that system, I tried it for a month. I practiced, it just didn't really work out, sadly. So I was pretty happy when I found out about Toki Pona. Because in Toki Pona, instead of using syllables, we get to use words as the basis. So now we're working in a base 120 system. So consider our encode function, right? Our encode method with the English alphabet. English is 26 letters, right? And that means if we're using the same key space as the English language, we're going to have 26 letters to shift by, like with the Caesar cipher, right? You can only shift 26 meaningful places. That'll give us our ciphertext. And with decode, it's the same thing. We have the English alphabet, which is 26 letters. And there's only 26 ways of transforming it because you can only transform it to other stuff that exists in that space, right? And that'll give us our plain text again. But instead of doing it with base 26 or base 120, because that table is going to be gigantic to memorize. That's going to be like 30,000 entries, right? We are going to do it with base 14 instead, which is the experiment we did earlier. So consider, consider the encode function with only 14 letters to worry about encoding and decoding. But yeah, that's pretty much the idea. And in practice, it looks like this. This is the table you have to memorize for the algorithm for encoding a message. So I have an example here, the Sina Ken Ala Ken Kuteyami example. We're going to use this key as a key for today. And so this is a completely randomly generated key. I smashed my keyboard and notepad to generate that. And so I mean, I did, but I'm just kidding. But yeah, so that's what I did for that. And here's how you functionally use the table. So S and T, right? So we look at the S column, look at the T row, and we find where they meet, and there it is, N. And that's the encode function. It gives us the letter N. Now the same works for decoding. You literally just have to memorize the table which reverses it, the decoding table. Given when your friend hears the letter N and they have the letter T memorized, they're gonna be like, oh, I heard the letter N. Here's the letter T, right? The first letter they sent us is S. Good to go, baby. Yeah, that's pretty much it. Now the final question is like, how do you speak it? Toki Pona doesn't have like an official like name for all the letters, so I just kind of came up with some a, I, U, E, O, and keselete e, and all that stuff. So basically consonant plus e sound. I might do something different, but for now I think it'll be okay. And so yeah, seke ake eme, right? Sinaken alaken kutiemi. That's like an example of how to say it out loud. But yeah, that's pretty much the whole system. It's basic, but it'll take a lot of practice. So and who knows if it'll even be usable? I want to find out. So if anyone wants to find out and go nuts with practicing something silly like this with me, feel free. Send me a DM and we'll try it out. But in the meantime, that's pretty much all I got. So I'm open for questions at this point. I'll leave up the slide though if anyone wants to play with it. But yeah, I'm open for questions. Now, if there's no question, I feel like some of you've got to have questions, right? I mean, come on. We're
I do have a
encrypted
question.
Language. Yeah, what's up?
Yeah. So the basis of this system is that you're using just the first letter of each word in the base set, right? Like the original Toki Pona dictionary. So
yes,
of course, it's going to be like even more of an assumption of reasonability about what you could possibly mean in one space. What do you have to do to refer to, say, less frequently used words that have a very frequent letter, like selo, for example?
A less frequency. Oh, cello. You know, have we talked about that yet in a Discord DM?
Like if a sentence began with like
have to exercise
"Selo
that
me
case.
pilin ike tan pipi ike," right? Like say if I had a sentence like that, the
I
sequence
have
SM, I'd probably
Here,
end
I'll
up
get to
thinking
you in
of
a
like
second.
Sina something, right? Some im word.
Yeah. So I can tell you how our conversations in DMs worked, and that's why we needed. That's why having a lot more practice and testing to determine the viability of this can be important. Because once again, this 14 reduction isn't the end product. It's just a stepping stone so that we only have to memorize 400 things. So we have to do this table. Because imagine this table, except instead of 400 entries we have here, it's 30,000 entries. The real one I want to learn is 30,000 entries, right? And then we won't have that issue you brought up. But in our DM conversations, what we sort of did is we kept things really simple. We started with Toki-a, right, to always like set context, and we gradually approached what we wanted to talk about. Otherwise, like that diverging universe thing would start to happen. I haven't tested that yet, and I would really love to. So that's the answer for that.
Sure.
Jan, yeah. So Jan Almax, you have a question.
Or kind of a response. If you added one more character that kind of acted like a bracket to say the thing between these two things is a word being spelled out and not, a single letter representing a whole word.
Oh, okay. So like some sort of like code switching operation, right? So if we had a code like a escape character type thing, maybe.
Yeah.
I feel like that could go a long way. Like especially when you take a look at our previous. Let me go back to the very first example. So see how I have Toki A with an X, or sorry, Sinaken mi with a question mark? There is so much information that question mark adds, in my opinion, because now you know the grammar structure of the sentence. You know, it gives you so much information. So yeah, I think an escape character could definitely help, even with like different Nasin too. Like I just assume Nasin Pu with this. Actually, yeah. So like the A or Keen thing, right? That they become the same thing with this system the way I defined it for now, but extensions can also probably make it way more usable and still meet the goal of prototyping. But yeah, absolutely. Does anybody else have a... Oh, did I answer your question though, by the way? Or your comment, I guess.
Yeah.
Awesome. Does anybody else have any questions or concerns? Because I feel... Oh yeah, Nia, what's up? Mikute. Mikanala Kutiesina. Is your microphone off? I wonder what's going on. Mikanala Kute. If you want, you can send it to me in Discord. I can try answering your question there. Just send me a DM. Okay, cool. I will... Yeah, so we're gonna do the Discord thing and we'll just check it out for a minute. Let me check my time. Okay, we have some time. We're good.
So before his questions, I would like to do some bit of simple question about the Caesar cipher in this encryption system, because in the case of Caesar cipher, we have to specify the number of let's say shifting.
Yep. Yeah.
How to specify this?
How to specify the number of shifts. So that depends on like the actual scenario in which you're using the cipher. So I have been using this like talking on the phone example, right? So say you're two friends, you're talking on the phone, but you want it to be kind of like secretive. What you do is when you're still at work or at school or whatever, this is called out of band. Basically just out of band, like not on the phone, you exchange the key. And so, the Caesar cipher doesn't handle key exchange, this algorithm. So you'd have to do it some other way. Yeah. Does that answer your question?
Yes. Thank you.
Yeah. Thank you. Excellent question.
We have to send the number in the plain text or the other encryption system, right?
Yeah. I mean, my hope is. Oh my God. Oh my gosh, let's go. Funnily enough, you just reminded me something that I didn't work into a slide. I had a fun like RP kind of idea with this system, if we could get there. Basically, I was concerning like some sort of like fantasy kind of world where different regions, like say everyone could speak like Toki Pona or something, right? But different regions have different ancient legends and lore, right? And so one thing that you could use for a key, it wouldn't be secure, but imagine using like some sort of like tale that everyone has memorized by oral tradition. I think that would be super funny to use in a system like this. And then you apply that oral tradition legend to your plain text to encode it. I don't know. I think that could be fun.
I was going to say, in that case, all you would have to communicate is like say, a book by a particular author and then like maybe a page number, and you could totally get that done. You wouldn't even necessarily have to have like a pre-existing story. You just have to have somebody else's story that's like around.
Yeah. Cool. I am checking my Discord DMs to see if Nia sent me the DM. It looks like, oh no. Okay, do you have any interesting examples of the parallel universe that would pop up? I'll have to get back to you about that offline. Yeah, sorry about that. But I will follow up on that. I do, honestly, if people do find interest, I want to do like a blog post write-up on that as well. And I'll get into those conversations during that write-up later though. Heck yeah. But thank you. That's a question. Man, that would have been a good slide. But that's okay. Does anyone else have any questions? What's up?
Are you going to release the slide presentation system so other people can do presentations in this world too that work?
So that's a question I actually wanted to reach out to you because you're the person who invented the systems.
I'd be happy for you to release it, but you put it all to good use, so.
Oh, thank you. Yeah, I appreciate it. Yeah, so Leoma here actually helped me create the avatar for this presentation we did today. Leoma created a Unity editor script, which takes like a PowerPoint presentation that's exported to PNG files, stitches them together, generates an animation, creates a whole UI on my wrist so I can do the whole thing. It's amazing. And so, yeah, I mean, I'd love to I guess clean it up just slightly and then release it. Absolutely.
Coordinates for this world, so you can set it up so it puts the correct place in the world for this room.
Yeah, and that's actually another thing. So Leoma taught me how to anchor objects in the world. We're actually running out of time. I'll keep it brief. Anchor objects in the world, but on an avatar, so I can just like go in any world. I have this avatar also set up for like the black cat and the great pug, and I can give the same PowerPoint in those worlds as well. But anyway, I think we're out of time now. So thank you everybody. It's been like super fun. Yeah.
Wow.